Hi, good morning to all. In this session, we have to discuss about knocking and anti-knocking character of fuels, octane and cetane values of the fuels. So first knocking. So knocking is a kind of explosion that occurs inside the internal combustion engine due to rise in pressure. So that gasoline vapor and air can be mixed together in the ratios of 1:17, and that has been used as a fuel in internal combustion engine. So this air and vapor mixture can be ignited by electrical spark. So this mixture can start to burn. During that burning, the products will be formed as the oxidation product. So that product increases the pressure and pushes the piston down the cylinder. If the combustion proceeds uniform, then there is no problem for knocking. If it is not uniform, then incomplete burning of this gasoline and air mixture results in the deposition of some of the constituents of that fuel, which results in the continuous knocking of the internal combustion engine. So this knocking property can reduce the efficiency of the engine. So good gasoline means it should resist knocking. So there is a relation between structure and the knocking. That means knocking tendency of the fuels depends upon their structure. If the fuel constituents are having a linear structure, then they are having more knocking tendency. And these linear chains are having more tendency than the branching chain, and the branching chain are having more tendency than cyclic chains. Cyclic chains are more than olefin, which is more than aromatics. So that knocking tendency will be decreased when we move from straight chain to aromatics. Further, that knocking will be decreased or anti-locking character will be improved by blending of petrol of high octane number with petrol of low octane number. So what is the octane number? Octane number means the percentage of isooctane present in the mixture of isooctane and N-octane. So if you consider the fuel which is having both isooctane and N-octane, then we have to calculate the percentage of isooctane present in that mixture. If isooctane is more, then octane number will be more. If isooctane percentage is very less, then octane number will be less. If octane number is very less, that means branching is very less, means that fuel will be resulted in the knocking sound. So if we mix that petrol with high octane number, that means a petrol which is having a more anti-knocking character, and this is added to petrol with low anti-knocking character, then that knocking lacking in that knocking will be compensated, and it can be improved. Then sometimes this tetraethyl lead can be added to the petrol to reduce that knocking tendency or to increase the anti-locking character. So nowadays aromatic phosphates are used instead of tetraethyl lead. Then leaded petrol, that means that tetraethyl lead is added, tetraethyl lead or triethyl lead is added to the petrol, and that petrol is called as a leaded petrol. So during that knocking, this tetraethyl lead will be decomposed into lead radical and ethyl radicals. These ethyl radicals captures the free radicals that is existing during the knocking process and it terminates that knocking. So that results in the formation of lead or lead oxide depositions. So deposition of this lead and lead oxide is danger for the internal combustion engine. So it has to be exhausted by adding ethylene dibromate. If you add ethylene dibromate, that reacts with the lead and it converts that lead into lead bromide, which can be easily removed from the internal combustion engine. So existence of this lead will be resulted in the severe environmental pollution. So nowadays, to avoid this environmental pollution, we are using aromatic phosphates. So next, octane number. So octane number is the percentage of isooctane present in the mixture of isooctane and N-octane. So if the fuel with the highest percentage of isooctane, then it's called as a octane number 100. If a fuel with the lowest isooctane or highest N-octane, then that is called as a low octane number, and octane number values will be 0. So if the fuel with more branched chain constituents will be resulted in the anti-locking agent. So fuel with very less branching and very high linear chain constituents, then that anti-locking ability will be very less, and it results in the knocking sound. Then the octane, cetane number and cetane rating. Cetane number is it is a characteristic of knocking characteristic of diesel. So for petrol we are taking octanes number. For diesel we are taking as a cetane number. So cetane, it is a cetane. Otherwise we can call it as hexadecane. So the cetane is having a short ignition lag. So that number was given as 100. So 2-methyl naphthalene is having a ignition lag is very long, and it can be denoted as a 0. That means cetane number is 0. So percentage of hexadecane present in the mixture of cetane and N-cetane and 2-methyl naphthalene, that is called as cetane number. If a cetane percentage is more, then that fuel will be very less tendency for knocking. If cetane number is very less, then the fuel will be resulted in the highly knocking agent. So the cetane number decreases as per that as follows. So N alkanes are having more cetane numbers than the cycloalkanes, which is having more cetane values than alkenes, which is having more than branched alkanes, and aromatics are the final. So cetane number of diesel oil can be increased by additives called dopes, ethylene nitrile, isoamyl nitrile. If we add these, we can increase the cetane number.